And welcome back to Better Through Tech. My apologies, everybody. It's been a couple of too many days since I posted. If you all recall, college, fun stuff. Had to wrap up my finals, and I had to get my new classes up and going, and had to sit down and figure out where my free time was going to be at before I could sit down and start doing my recordings again. But now that I have that out of the way, I figured we'd get into how to use LED strips. So these are going to work a lot like the LEDs that we have used in the past, but now we're going to step it up a little bit and we're going to be using strips of them. More so, we're going to be pushing the 12-volt versions in this episode, so we're going to be using external power supplies to power them. So, what does that mean? We're going to use an old code that we've used in the past. We can reuse the code, so I'm not really going to focus on too much of coding on this episode. What we're really going to focus on this episode is we're going to set up the LEDs, how to control them through the Arduino, through a nifty little piece called a transistor, and we're going to be using external power supplies to hook them up. And we're going to set all that up, and we're going to light up some colors. We're going to light up the room tonight. So, with that, as you can see, we have the code from the previous episode, or the episode before that. Same episode, the same program. So we're not changing anything there. You may need to change the pins. I have just edited out the button because we're not going to use it on this one specifically. Edited it out, commented it out here, and I commented it out here. For this specific part, I edited this out as well because I'm only focused on the RGB value at the moment. So this is going to run the function RGB, if you remember that this code down here. If you want to leave it on, it's fine. If you want to leave the button hooked up, that's fine. You can cycle through all this with the RGB LED strips. It'll still work just the same. But I'm more focused on just the RGB value itself, so I'm only having that run. And so with that, let's switch over to our Tinkercad, and we'll show you what we're playing with. So this P value here and this N value here are going to be our representations for our transistors. These, I do believe these are packaged in, what is it, a 190? I think it is. Give me 1 second. Let me look it up real quick. So the package that we're using here is a TO92. That's the package that we are going to be using for the representation on Tinkercad. The one that we'll actually be using on the Arduino is a little different. It is actually packaged in a TO-220. So they come in a number of different sizes and shapes and power abilities. But we're going to just use this one on Tinkercad to keep things simple, just so we can get the representation down and see how they're wired up, how they work, and what it is that they do. So that way when we switch over to the Arduino and its wiring, it's a jumbled mess of wires, but at least you'll get an idea of where everything is going and why. So, you see I have three LEDs set up here with 3 different output wires. We have pin 3 wired to the PNP transistor. We have pin 4 wired just directly to the LED, and we have pin 5 wired up and around to the NPN transistor. And so what this means is that these will work a lot like a common anode or a common cathode LED. It's a little confusing at first because they actually work a little different, because you'll notice this NPN, or this N transistor, goes to the LED and it's pulled high. It is on the high rail. Okay, I don't want to do that. But it will act as if it's this LED over here that's pulled to ground or pulled low, so a common cathode. So they work a little opposite, but the basic idea is still the same. If you remember our other episode of syncing and sourcing. Sorry, I had to think about that for a second. If you remember that episode and what works and why, these work exactly the same way. other than only you'll be sending the signal to the transistor instead of actually syncing or sourcing directly through the Arduino. So the best part about this is if anything ever happens, you will have the resistors to isolate your microcontroller from your transistors. So if you smoke anything on the circuit board, odds are it probably will only be on the circuit board and not your microcontroller. Unlike the other episode we did, if you mess something up on there, you will probably smoke the microcontroller itself. So the PNP, as you can tell, it is got three holes. They all have three legs. It just depends on how they're set up. But these ones specifically have three legs out the bottom, and the PNP will be pulling power from the positive rail, right? They'll be pulling power from the positive rail and sending it to the emitter, which is the emitter. This is the emitter leg, so they'll be pulling power to that. The middle is the base. That is like your switch, or if you will, like the valve on a hose. The more you open up the valve or the more you close the valve, kind of controls the flow, right? Well, this is exactly the same idea. So as you use your pulse width modulated pins to control the amount of electricity to turn the LED on, this will adjust it, but amplify the power. And then you have your collector. Your collector is your output, at least from this direction. It is your output. It will send power out. It'll send it down through the anode part of the LED, and it will come down. I don't know why it's doing that. From the cathode, and it'll come down and it'll be pulled down through the resistor to ground. Now, if you look at the NPN, it works exactly the same way, but in reverse. So the best way to think about this before I explain the NPN is that the PNP controls the flow before the LED, and NPN will control the flow after. So the NPN will send power through the resistor, through the LED, and it'll collect it up into the NPN transistor, and then it'll emit it to ground. And then, of course, the base is exactly the same thing as the other one. That is like your valve. That's what's going to control the amount of power going through there. So it'll control how open the gate is, and that will control how much electricity is flowing through, and thus dimming the lights. And then, as you can tell, oh, and I moved the whole board. How the heck did I do that? Yeah, probably something like that, huh? And then lastly, we just have a regular LED connected to pin 4 that's pulled straight to ground. So that way we can see how this works. And so I'll open up the code because I did jot down a little bit on here. Move this out of the way a little bit first, and we'll open this up. And so as you can see, we have LED 1, LED 2, and LED 3 all putting out on output. Now as you can see, now the difference is here, this is where it happens. As you can tell, the LED 1 is low, right? And then on the flip side, it's high over here where everything else is low. So when we start this, as you can see, everything is blinking at the same rate. So like I had mentioned before, this works exactly the same way that a common anode or a common cathode would work, as far as the differences on turning on and turning off. The weird thing, like I had just mentioned, is that the NPN will operate like it's pulled to ground. The PNP will operate like it's pulled to the positive rail. So the PNP has to be pulled low in order to turn it on, like this is right here, and it'll have to be pulled high in order to turn it off. Because if you look at LED 3 is on pin 4, and you can see this is pulled to ground, and they're all on the same page, right? So now if I stop this real quick, and if I match this up, and give this high, and we put that one on low, so all three pins are on the same high-low sequence, right? Now you see that it's doing the opposite of what the other two are doing. So there's a reason why I'm pointing this out, because the transistors that we're using on the Arduino are PNPs, but we're going to be pulling them high in order to turn them on, which is very much like a common anode, which essentially is how I have the LED strips on here connected. So I don't want you to get confused because of prior videos of how we had common anode and common cathode stuff set up. So as you can tell, that just the pin 4 and the NPN are on the same sequence, and the PNP is by itself doing its own thing on the opposite side. So that's the reason why I wanted to show you this. And then let's go ahead and stop this. So we are done with this. So before we get started getting a look at the Arduino itself, this is going to be the actual setup that we're going to be using. I want to make sure to make it clear that the demo that I displayed here on Tinkercad and then the actual setup is not exactly the same. It's just kind of the basic overview of the setup. So I wanted to show you that this is how it's actually going to be set up. Don't ever connect a I mean, if you're using 12 volts, it's fine. I wouldn't recommend it. I kind of like keeping the Arduino power supply separated from the main light supply. It's just a personal pet peeve of mine. You can put 12 volts into it. I would recommend hooking it up into the barrel jack, because that's regulated and filtered. It'll be keep it happier and healthier. You can plug it into the V in here. It will work, but if you start running like 24 volts or bigger systems, you're not going to want to plug this power supply. Well, this represents the power supply, but you don't want to plug this power supply directly into the Arduino because you'll ruin it. So the general good rule of thumb is keep the Arduino in its own power circuit and you use the power supply to power everything else. So as you can tell here, I don't have 5 volts connected to anything. Nothing is connected to this. It's running on its own power through the USB, or you can use the barrel jack, or like I said, the voltage in on a different power supply. But the ground on the other hand, connect the ground to everything. It doesn't matter if it's 5 volts, 10 volts, 12, 24, 36, 72. It doesn't matter what it is. You can ground everything on the same ground plane. It is okay. Like I've done here on this the simulated power supply, I have it grounded to here, which also is grounding it to the Arduino. It is more than okay to do that. It's just, you just want to make sure not to connect multiple different powers to the same system, but you can ground everything on the same system. That is okay. So the ground's going up around here and is also connected to the ground on the power supply. That is perfectly all right. Nothing bad is going to happen if you do it this way, and actually, matter of fact, nothing will work if you don't connect the ground to everything. But with that being said, here's the TIP 120s, and as you can see, that these are set up exactly the same way as the layout that I had just showed you with the other 2 transistors on them. They don't have the specific type of LED strip that I wanted to show you, so I have these connected to light bulbs just as a representation of them working. But this is the actual setup that we're going to be using to take a look at with the Arduino. We'll get the camera turned on here and we will start recording so I can show you what is going on here. And okay, so now we're going here. Let me move my mic because now I'm kind of stepping a little further away from here because I gotta be behind the camera. So as you can tell how I have this set up, let me adjust this a little bit and we'll get ourselves zoomed in here so we can see exactly what's going on. I know it's a huge jumble of mess of wires going on here, but as you can tell, that what we got going on here on the Arduino is exactly what's going on the Tinkercad, right? So why do we have the resistors here? You always want to isolate your Arduino from your power board, your power section of your board. What do I mean by that? The resistors. And it's a general good practice. For this, it's not too big of a deal. You can use smaller resistors for what I have on the table. But if you're going to be pushing 16-foot strips and trying to power them, you're going to want a very much bigger resistor like what I have here. I got set up on here is a 1 kilo ohm resistor, and that's exactly what I have for the example on the table. I have 1 kilo ohm resistors. It's a little overkill for the example I have set up, but I would rather show you properly so that way if you grab a 16-foot strip, you don't burn out a resistor or potentially fry a pin on your Arduino. So you want to keep them isolated because of the transistors that we're using. And I probably should have pointed this out first. For this example, I'm using a tip 31 transistor, but you can also use a tip 120 resistor. These are Darlington type transistors, and so you want to have a resistor in place between the Arduino and the transistor itself, so that way it doesn't try to I do believe it's over. You want to limit the base current, so that way you don't overdraw from the Arduino and potentially blow out a pin on your Arduino. You don't want to do that. So anytime you're going to be connected to anything with bigger power, it's generally a good idea to try to isolate your microcontroller from the power module itself. So use at least a 1 kilo ohm resistor to isolate your output pins from your power board. That way you can keep it safe and everything stays happy. Yes, you don't have to use the resistors, but I really wouldn't recommend it. If you're just going to set something up real quick to test it, maybe only going to use it for maybe a couple minutes, yeah, sure, I'm pretty sure that'll be fine, but is it really worth the risk of blowing a pin and then having to pop the microcontroller off of the Uno itself? It's just better off to be safe to do it this way. So what we got down here is we have 3 tip 31 transistors, each one for each one of these legs or strips for LEDs, connected to a 1 kilo ohm resistor, and that goes to the Arduino. So if you remember in our previous episode, I do believe it's the RGB episode, this is going to be set up exactly the same way as the pins work. It's just, and the code, it's just the input, instead of going to the LED, the input will go to the transistor, like what we have on screen here. So let me get this plugged in real quick, and we will turn off this, and then zoom this out, and you can see that this is exactly what your RGB strip will do when it's running. I have one red, one green, and one blue strip, so they're all on their individual, on their own individual leg. But if they were all combined together, this is what the RGB strip would technically be doing. And then this is how you would get your wash of colors to get your the full spectrum color wash between all the LEDs. So now this gets into the whole idea of how do we power this, right? Well, obviously you can't just connect all of this stuff directly to the Arduino and expect it to be okay. You will massively overdraw the system, and you could kill the Arduino, or you could kill a pin or a leg on the Arduino, or worse, you could just kill the whole system and essentially brick an entire Uno, and you don't want to do that, right? So we have to figure out how to externally power the system. And just case in point, let me hook this up real quick because I unplugged it because I was messing around with something. Just case in point, because you'll see something here. I'll connect this up, and I can actually unplug this, and it's still running. So what this shows is that we can actually power the Arduino externally and not just through the USB cable. Yes, you can plug it through the USB, and there's a specific barrel jack for this kind of stuff, but you actually have a voltage in here. Let's see if I can zoom in a little bit. Maybe it can come in a little bit. There's too much shadow there. But there's a voltage in there, and you can actually send power into that. I wouldn't recommend anything over 12 volts, because that could lead to damage. I think the absolute maximum, I do believe, is just short of or right around or just under 20 volts. But I really wouldn't do that, because then it'll create a bunch of excess heat and could damage the system. So I would try to keep everything connected to this, the barrel jack, or this. This does 5 volts. You don't have to worry about it because it's automatically regulated. But I'd try to keep everything to 12 volts or under, just to keep the system happy and safe. Okay, let me unplug this. I didn't grab a big enough power supply for this to power the Arduino and all 3 strips at the same time. So the power supply I use is kind of freaking out a little bit. I know, shame on me. I'm having this episode to show you how to properly use this, and I didn't even grab the proper power supply. Doing real good. Anyways, to sidestep that, after you get your say again, scroll moment. Let's see where I was going here. Power supplies. Okay, so how are you going to power this? There's a number of different ways you can power this. If you have a wall wart, that you're not using, or if you have an old laptop power supply that you're not using anymore, they could be used to power these things. You have to be careful. You can't just grab like an 18 volt or a 20 volt or 36 volt system just to power this stuff up, and it doesn't work like that. And you could fry the LEDs. You gotta be really careful with this stuff. LEDs are gonna come in three major packages. Sorry, anything beyond this has to be constructed by hand. There is a way to go outside of what I'm about to tell you as far as voltages, but as far as off-the-shelf stuff, it only comes in either 5 volt or 12 volt or 24 volt systems. Those are only three options you'll get off the shelf. There is ways to go 36, 72, but you have to rewire the system, rewire the way the legs are connected to stack them. We're not going to get into that right now. But so you'll have 5 volts, you'll have 12 volts, and you have 24 volt systems. So what do these power supplies look like? Okay, so here's a good example here. This is just a regular old power supply. Let me unplug this. We don't need this anymore. I think this kind of served its point for the time being. We'll slide this out of the way. Oh yeah, if you got live wires like that open, don't move it while it's plugged in. It's not a horribly good practice, but I didn't have any other way to set these up. So, let me move this out. Okay, so this is just a regular LED power supply. There's nothing special about it. It doesn't really do much. It's just designed specifically to be put onto a switch and just turned on and off just to power lights on and off. There's nothing in between. But, as you can tell, this is a 12 volt. Sorry, I got to get behind the camera so I can see what I'm doing. This is a 12 volt system at 100 watts. So, these are 12 volts. These LEDs are 12 volts. So, the good thing is that you can plug this in directly to this and have no problems. You don't have to worry about any microcontrollers. You don't have to worry about any special resistors or anything to load balance, so that way you don't blow something up. I've been doing it for years. It's quite all right. The only thing you have to be careful is the voltage. Systems have to have the voltage no matter what. You cannot go over the voltage. If you go over the voltage, you will damage it. So if the LEDs are rated at 12 volts, you have to have a 12 volt power supply. No ands, ifs, or buts. I have a couple of LED strips in here that are 24 volts, and so what does that mean? You have to have a 24 volt power supply. You have to match the voltages. There's no way to get around it. You will damage the system if you don't match the voltage. So the best way I like to think about it is the system has to have the voltage. It can have at least the required amperage. So it has to have voltage. It can ask for the amperage. So it's okay that if it's 24 volts at 100 watts, because what we got here is 24 volts at 4.25 amps. So it has to be 24 volts, but it can be 2 amps. It can be 4 amps. It can be 10 amps. The amperage is okay. Amperage is not what's going to kill your lights. It's going to be the voltage that's going to do it. Same thing with the Arduino. You can put 12 volts into it at 5 amps, and it'll work just fine. But if you put 24 volts into it at 2 amps, you'll fry it. You'll kill it. So these are just regular plain Jane power supplies. There's nothing really special about them. They're only designed to be on a switch to be turned on and off. I tried putting them on a dimmer, like the Arduino dimmer we just had going on, but there is a feedback in these and they hum really bad. It does work, but it gets really annoying. So what are your other options then? Well, you could, sorry, I had to put those out of the way. You could just go with a regular battery. Wrong way. You could just go with a regular old battery. This is for a uninterruptible power supply. So, yeah, there's a little dust on it. It's been sitting for a bit. You could use these to power the system. You could use lithium-ion batteries, like the 18650s. I don't have any up here for an example. But as long as it matches the 12 volts, or whatever the voltage is of the lights, it will work. if you want something a little nicer, I use these all the time. Meanwell makes amazing power supplies like this guy right here. This is a 24 volt power supply, but it also has the capabilities, as you notice, it's got 3 legs on it. This is live power coming in. This goes to your light, and this is a dimmer. So you can actually have these with built-in dimmers, and as you can tell, this is a very thorough case. This is waterproof, so this can actually be mounted outside in the weather. I wouldn't recommend direct weather, but this thing could easily sit up underneath your roof, over the overhang of your roof, and it'll be just fine. Just gotta make sure to waterproof these. But you can put a pot on there, a potentiometer, and you can control your lights just through this alone. If you don't want to go that route, you can use other Meanwell products like this one. This is a vented case. This is meant to be put in a housing. But you can use live 120 volts, and then you get the voltage out. This actually comes with a potentiometer built in if you want to change it from there. Not as easily adjustable as the other one, but you can use power supplies like this. These are the ones I'd recommend for in-the-home use, because these are the ones. Meanwell makes amazing power supplies, and they make it's very clean, very, I can't think of where I was going to go with that, but they make very clean energy power supplies that LEDs work very well off of, and you have no problems. Even with the example I just showed you, it'll work perfectly with these. I have one of these set up in my kitchen right now, actually running the lights in the kitchen. And that's going to be an upgrade down the road that we're going to be working on. But yeah, it's running off one of those too. Well, what happens if you need something a little smaller, like what I'm about to show you here? This is going to be the replacement power supply for the lights in the kitchen, because I'm going to be going with a completely different setup. But then you can have out-of-case power supplies like this little guy here. This is just a 5-volt power supply. Nothing big, nothing crazy, but it's enough to power the Arduino, and probably not much of anything else, but it serves its point, and it'll do what it needs to do very well. But yeah, so there's a couple of options of what power supplies look like, and what kind of options and ranges you could use for in the house, outside. So how do you properly size a power supply to your lights? Well, let's go over it. Let's show this here. So this right here is the basic layout. I know, right? A little bit of a groaner here. We got some math. Oh, geez. But this is really important. If you want to properly size your power supply to your lights, you want to size it appropriately so that way you're not pushing it too hard. You don't want to have, what would be a good example here? You don't want to have, these are for the next episode, but I'll show you these anyways. You don't want to have something like this where it has a 90 watt reading. You don't want to be using something like this where it's got a 90 watt reading and get an 80 watt power supply or a 90 watt power supply. I don't know if they make 90 watt. No, yeah, they should. But you don't want to ever go under or exactly at what it's asking, because then you'll be asking the absolute maximum of what that power supply can give you, and that is likely to burn out your system very quickly. So here's a couple little ways to figure out how to get, if your power supply doesn't show the watts, most of them should do so. Not all of them will. See, like this one right here, this one is only showing, output at 12 volts at 6 amps, right? So we have voltage and amps. So volts and amps, right? So if we get our calculator out here real quick, and we get our volts, what was it? It was 12 volts at 6 amps. So it's 72 watts. Oop. So you have 72 watts right there at 12 volts and 6 amps. So now you know how many watts you're dealing with on that system. And that's perfectly fine. This is really more than adequately sized for the project it was chosen for. Probably wouldn't be the best for a 16-foot strip of lights. But it works very well for the task it was given. So you have your watts. Well, if you need to figure out your amps, You know, you can take your watts divided by volts, which will give you your amps, or your watts divided by amps to get your volts. So everything feeds back into itself. Where the heck did I put that at? So, for example, if you had this, if you look down here, so you got your 24 volts. So we have our 24 volts, and we times that by the 4.25 amps, right? That's 102 watts. Actually, that's a little over, actually. This is rated for 100 watts. But if you only have your watts and your amps, so I'll say 102, so the watts, right? And then we're going to divide that by the amps. We know the amps is 4.25. 4.25. It's not going to work with two divide signal signs there. But 4.25, 24 volts, or 24 volts. So you can, if you're missing one, you can use any of these formulas to figure out the other and to get you where you need to be. Now, hopefully that wasn't blurred out the whole entire time. I apologize. But you can use these to figure out one or the other if you're missing any of them. But the biggest thing you need to know is the 80% rule. The 80% rule states that you should never use more than 80% of a power supply. So, great, okay. How do you figure that out? Well, we're going to use some pre-algebra to figure this out. So, what do we got? We'll go back to our smart LEDs. Again, this is for the next episode, so don't get too excited yet. But you can see this says 90 watts on it, right? You can see it right there. It says 90 watts. Well, how do we figure out what 90 watts is 80% of? How do we figure that out? Well, it's super easy. So we need, sorry, I'm left-handed and I'm standing on the left side of the table and everything's going kind of weird here, so I apologize. But how do we figure this out? We figure this out by 0.8, because that's 80%. So it's 80% of what? Right? Is equal to 90 watts. So that's the basic way to lay it out. And I'm doing this on purpose. Once you figure out the basic form of how this is set up, it's a lot easier to put it in the calculator. But it's really important to structure it like this. 80% of what equals to 90, right? 90 watts. So we're going to bust out our algebra skills here, right? And we're going to move that 80 over. And now we just turn this into a fraction, right? So 90 over 80%. So what is that? We'll get it back into our calculator here again. We'll set up our fraction, and we'll say 90 watts is 0.8. So 80% of what? It's 112.5 watts. So that's how you can figure out that that is 90 watts is 80% of 112. 112.5 to be precise. So you can say, you can figure out with that. Like, okay, cool. So I need a minimum of that because that's the 80% rule. So from this perspective, it's always great to round up. So you would be more than okay to get a, what, 12 volt power supply that's rated at 120 watts. If you were running 12 volt LEDs, you can get yourself a 12 volt power supply rated at 120 watts because all that extra power is going to come from the amps, right? So now, if we need to figure out how to get what the amps of that is, so we need what, 120. We need 120 watts, and we just figured out that. So we need amps. So we got wattage, right, and volts. So we need 120 watts, and we're going to divide that by 12 volts. So we need at least a power supply that's 12 volts. I gotta quit doing that, my apologies. So we got 100, there's 120 watts divided by 12 volts. That gives us 10 amps. So now you know that in order to properly power maybe these lights, that you need a power supply that's 12 volts at 10 amps. And that will be over your 80% rule, but you'll be in a very happy cushion, and your power supply won't overexert itself and sweat too much and then eventually blow. that should very easily give you a many number of years of very happy functioning, a very happy usage out of it. So, sorry, I apologize. Some math there, you know, but hey, you wouldn't be watching this if you weren't interested in becoming a either an electrical engineer or software engineer or any of the engineer fields. You wouldn't be watching this if you weren't interested, right? So, lastly, let's talk about the different types of LEDs. I know I covered a lot of it already, but there's so many different types of LEDs you can use this stuff with. It's so impressive. There's two different things that you need to keep track of. Or actually, there's more than two. My apologies. My two comparison pieces I have up here, I only have two, and for some reason I got two stuck in my head. But these here, these LED strips come in densities. And there's a different density amount that you can get that these things come in. Sorry, I gotta put my hands down here and show you here, because these things don't want to sit flat. All these strips will always come with like 3M. These are really nice ones, so they come with 3M, double-sided sticky tape to hold them down. Always make sure to clean your surfaces first, or else they won't stay forever. But you can see that there's a density of these. So the strip on the right is a density of, what is it, 150, 120, 150 LEDs per 16 feet. So if you had 16 feet of this stuff, you would have 150 LEDs. So it's a 150 LED ratio. This one on the left has a density of 300 every 16 feet. So that means for every 16 feet, you'll have about 300 of these. I do believe that is the ratio. I apologize if I get that wrong. I'll make sure to get the right information now to you if I have it wrong. But the density goes up a lot higher than that. As you can tell, like this, these are way more densely packed. I do believe this one is, oh geez, what is it, 400 or 600, I think, maybe, possibly. But yeah, so you can tell from the strip I'm holding here, this is just a solid color. I think this one was the blue one, but these three up here are just solid one colors. Both of these right here in my hand are both RGB strips. These are both regular, you can call them dumb or analog LEDs. And I'll get more into the point of that next video, because we'll be talking about smart LEDs. That's the reason why I refer to them that way. But you have to have a wire for every pin to control each RGB value. And both of these, I do believe, are set up as common anode. But yeah, so both these are both RGBs. And you can pick whatever color you want with these things, and figure, like just like our other video where we did with just the LED itself. These will work exactly the same way, as long as they're used through the transistor to bump up the power, so these can use them. And yeah, you can easily light up an entire room, an entire area with these things, right? Really cool stuff. Well, okay, so what if you're not really so wild about that, or you want to have a little more functionality? Well, you can also move on to something like this. So you want to have maybe, yeah, you want to have white in there too. Instead of just maxing out all three values to create an RGB version of white, you can actually get something like this. Let me make sure this is focused in here. You can actually get something like this, which has the 50/50 value LEDs on it, but it'll have the RGB LED and a white LED on it. So, as you can see, there's a couple more wires on there than just the 4. I think there's 5 here. And it gives you that extra output, so that way not only can you control each part of, the camera keeps on blurring out a lot here, but not only can you have control over each leg of these RGBs, now you can control the whites. And so if you don't have a lot of room, or want to save room, don't want to buy 2 different strips, you can buy something like this, where it'll give you all 4 values all together: red, white, green, and blue. So then you can have all 4 of them there. Another way to look at that, let's see if I have them up here. I thought I did. Yes, I do. I apologize. I have everything sitting on my table right now, so it's kind of a little bit of a mess. So, okay, so what happens if you only want white, but you want to change what is called the Kelvin level of the white? And what that means is you can change the I guess color of the white. I know it's kind of a little weird to say that because white light's white light, right? Well, this strip here has what is called cool white and warm white, and you can see the difference between the coloring in the LEDs themselves. Hopefully that's coming through on the camera. I'm not really sure if it is or not. But you'll have almost like a yellow, and then you have like an orange filter on the LEDs. So when one's on, it's a cool white, and when the other one's on, it's a warm white. And if you adjust the blend between the two of them, you can create any amount of cool white, natural white, and warm white. So if you're trying to set the Kelvin level of the white and set a specific ambiance, you can actually effectively change the warmness, I guess, warmness or the coolness of the white light to kind of give it an extra flavor, a little bit of extra change, right? Let's see what I got here. This one's not really too crazy or over the top here. This is just a standard 50-50, so it's a 5 mil by 5 mil LED. These are just white lights. They come in a number of different sizes and packages. This one's just the 50-50, just a regular old 12-volt system. So nothing crazy there. So if you wanted to... Okay, so what happens if you wanted to light up something, but you don't want the lights to point straight out? You want the lights to point at an angle, right? Well, you know what? They have something for that too. These are actually side-mounted LEDs. So, and the way it sits, the light will actually flash or shine that way. So the light won't shine up; it'll shine out from this perspective, anyways. So when you have it laid down or stuck to something, the light will actually shine out that way. So you can actually direct the light. So if you wanted to have this like really low profile, you wanted to hide these maybe in a china hutch or something to that effect, you could really tuck those in there and hide them, and it'll give you that nice angular light. Sorry, everybody, I know this is getting a little long. Oh, this is almost over, so I just wanted to... This is meant to be kind of a 101 anyway, so I kind of want to just give a big information dump, so that way you're more better informed about your decisions when it comes to setting up your lights. And what do I got here? These ones are really cool. I really enjoy these ones. These are like a flexi strip. So if you ever want to set up lights that need to go around curves, you need to curve them or bend them or anything like that, these are designed for that. These are designed to be bent and folded and twisted, so you can make these be able to fit around corners or angles. So if you don't have a straight shot, you could use something like this to get them to work. And yes, they do make those in an RGB value too. So that way you can fold them around, like maybe if you're going to light the top half of your kitchen on your cabinets, it's a good way to fold lights around if you got any crazy setups in there. And then one of the last ones I wanted to show you, because those are all 12-volt systems, this one alone, the LED package size, I thought it was posted on here. Oh, I guess they're not posted on here. These are a... holy cow, what size are these? I'll have to get back to you on the size of these. I can't remember. But these are a very much smaller LED package. They're a lot smaller, a lot thinner. But this is a 24-volt LED strip. So these could be used with that. So there's that backing tape again. They all come with backing tape. But you can use the 24-volt power supply to power this. And since it's just white, there's no crazy any other legs you have to hook up to it to get it to work. But any of these could be just hooked up to a power supply and just connected to a switch. So if you don't care about dimming, you don't have to use dimming. You can just connect them to a regular outlet or a regular room switch and use these as normal light in your room if you wanted to. Or if you wanted to dim them, they do have Home Depot or Lowe's. I'm not sure where you're watching this at, but those are the ones we have around here. You can get the dimmers built into them, or if you want to be really fancy like me, you could just program the system with an Arduino and probably not an Uno, probably, you know, like a Nano or a Pro or something like that. But something that's a lot smaller package, so that way it doesn't take up so much space. But you can just do your own thing and build your own light system, which I love doing. I think it's the funnest thing ever. You can take some pride into building your own system. So with that, that's kind of a general overview of setting these up. I'm going to close out with this. I will show a couple of quick vids of the Arduino running all the different LEDs I've showed you. I won't be talking, but I'll show them. I'll show them doing their function, their lights, their sequences. I'll show you all that stuff. But essentially, this will be the end of the video, or the end of me talking anyways. So there might be another minute or two of the lights so you can see them working. Let's see. I had to go over notes this time because I wanted to make sure I covered everything I wanted to talk about. And I do believe I covered a good majority of what I wanted to talk about. So this will be the part 1 of the 101's of how to use LED strips. There will be a part 2, but we're going to be focusing more on smart LEDs, which will be the WS series, which will include the 2811s, the 2812s. I don't have any 2813s, so we'll mostly be focusing on the 11s and the 12s. And we'll be focusing on going over... Sorry, I have a lot of LED strips up here, so I gotta dig for my stuff. But we'll also be going over the SK6812s. So, the 2812s are an RGB system, and the SK6812s are an RGBW system. And they are going to have their own video. They're totally different than these normal or analog LED strips, as there are microcontrollers in the LEDs themselves. So there's going to be a completely different way that we're going to be wiring these up. We're going to be introduced to some libraries and some new control functions. So I hope that you stay tuned. If you've made it this far, thank you. I appreciate it. I know this is getting a little long in the tooth right now. That's the reason why I'm going to break it up into 2 different episodes. Again, I appreciate it. Thank you very much for watching my video. If you need any help with anything, if we need help wiring up, need any help with code, hit me up. I'm here. I'm going to try and do my best to help you out. We'll get your projects underway so that way you can get to enjoying them, right? So, thank you. Again, I really appreciate it. Give me a like and a thumbs up, and I hope to see you in the next episode. Okay, I'm back with a real quick note here. I completely spaced this. Got so wrapped up in making the videos, I forgot to post this. This is my custom little board that I built with my 3 tip 120 transistors. As you can see, there's heat sinks on the back side of them. If you're going to be running the bigger strips, the bigger 16-foot strips, you're going to be producing a lot more heat on the transistors. It's really important to remember to add some heat sinks to dissipate some of the heat buildup, so that way these parts don't overheat and fail. So really important thing to keep in mind. Thank you, and I'll conclude this again with the LEDs. Thank you.